What's up, math scholars? We are doing a video today, starting at 17 and working backwards. So that way we'll have the harder problems done, and you can, with the substitute, then just work on the easier problems. Okay? Test is going to be Wednesday, so if you want to plan your calendar, that would mean the study party will be after school Tuesday, before school Wednesday. Sound good? Who's excited that's Friday? Yeah! Friday, Friday, Friday. All right, class. Do we have a complete set of partners? No, we don't have a complete set of partners. We do have a side. He's back there yelling side, side, side. He's right. We have side, 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 which means we don't have complete partners, and we have to use law of cosine. So it does look like on your formula sheet, I did provide you with all three versions of law of cosines. If you want to use the version that's on my board right here with a large C, that means you're going to need to label it up here as large C. So label angle X as large C. Pull it down a little bit. It'll help me write up in that corner easier. So large C makes the 10 a small c, and the 15 can be my small a. That can be big A. My 11 can be my small b. That can be big B. It looks like we're solving for X. Ooh, this is going to be a fun one. We're solving for an angle, so we'll need an inverse at the end, right? Okay, here goes. C squared equals A squared plus B squared minus 2AB. So you see that 15 and 11 appear twice. That's a great way to check that you're doing it right. And then cosine C, or X, whatever you want to put there. How about I pause the video and you try this by yourself? Because what people watching the video don't realize is we just did two problems like this on the board, okay? So you're going to hit pause, let the students try this. Beware. Do not subtract the 346 minus 330. That was your subconscious. Have you guys gotten to the part where you have to remember to use a cosine inverse at the very end? All right, you can kind of see my work. Just beware, you don't want to subtract your 346 and 330, and you do need to divide by a negative 330, not a positive 330. And of course, don't forget to do a cosine inverse at the end. The answer is 41.8 degrees. Moving right along, do we know a complete set of partners, class? Yeah, whose partners? 65. The 65 and 22 would be a great place to start this one off. Sine of 65 goes with 22. We're using the law of sines because we have a complete set of partners. Here's why maybe some of you are hesitant. X currently doesn't have a partner, but it's not going to be hard at all to find his partner because we know all triangles add to 180, right? So 180 minus 15 minus 65 is 100. So we're going to partner up the 100 with the X. So I'm going to pause the video and let everybody try to finish this by themselves, okay? All right, if you are stuck and you don't know what to type in, you take the 22 and you multiply it by the sine 100, and then you divide by the sine 65. I got 23.91. So any issues with the calculator? If you are going to have a calculator issue, just click mode and make sure you're in degree mode. It's good to check periodically that you're in the right mode. I did have a student that his mode switched back magically and he didn't even know how. So who knows? You good? Okay. Move them backwards. Ooh, we have a little word problem. 2 points A and B are on opposite sides of a building. A surveyor is choosing a third point C, 50 yards from point A. They already have it labeled. 32 yards from point B. They already have it labeled. It was a included angle measuring 98 degrees. How far apart are A and B? Do we have a complete set of partners, class? So what's that mean as far as our strategy? Law of cosines. Law of cosines. That big, huge formula right here. So right now it looks like the angle we'll be working with is large C, so we can use this first version of the formula. I'll put it on here so the people in the video can see it. This is the formula that we'll be using on this problem because it will be able to handle the cosine C, the 98. X will act as our small c, so we can put that in. The 50 and 32 will act as our A and B, so we can put those in. It's a pretty long formula. Now we're kind of lucky because this is the one where we can just type it in all at one time. And once you have all your numbers placed, I'll hit pause and let you kind of type all that stuff in and solve it out, okay? You'll have to use a square root at the very end. I should record. So I got x squared is 3969.35, but I remembered to finish it off with the square root. So they are 63 yards apart. That's what I have on my paper, at least. Is that looking good? And everybody else, though. All right, we're moving along to 14. It sounds kind of crazy because we got some people leaving for the pep rally, but we must continue our mathematical journey. Find the area of the triangle. We have two area formulas. We have that Heron's formula we learned yesterday. That's for side, side, side. And then we have that formula we learned the day before for side, angle, side. And that's what we're going to be using. So I'll jot it down. 1/2 BC sine A. So if we want that formula to be compatible with this triangle, I would label this my large A, and then these guys my small b and my small c. All right, so we're going to put the b of 10 in, the c of 13 in, and then the sine 100. This is not a hard formula to use at all. You can just type it in right straight away. I got 64.01, so check that that's right. Let me know if I did it wrong. I might have typed the number wrong, who knows. All right, we're solving for theta. This one's pretty easy to start, a little bit harder to finish. If I'm solving this equation for theta, what will I do to both sides? Someone knows. Yes, good. Cosine inverse. So we'll do a cosine inverse here, we'll do a cosine inverse here, and we'll see what angle the calculator gives us. So go ahead and try that. I have jotted on my paper that the calculator gave me 70, but definitely check me. Now this is the one where we kind of have to use reference angles to kind of get to where we need to go. So right now my calculator says that somebody that would have a cosine value of 0.34 would be 70. So that angle's measure 70. But they're telling us that's not where they want the answer. They want the answer between 270 and 360. So here's 270, here's 360. We're going to use reflection to get it down into that quadrant. So you reflect this down to here. That also makes our reference angle a 70 again. We reflect it over the x-axis. So how would I figure out where that pink dot is? 360 minus 70. You don't want to use the 270. 360 minus 70, 290. Yep, that's what I have. 290. All right, one more and we're done. We'll be done after number 12. Okay, that's a great goal. We're going to hit it perfectly. It's 9:50. All right, we'll end the day with a really easy one. 405, that's a pretty big number. How can we make it more usable?
360.
Uh-huh.
Yeah.
So I wrote down that that's 45. You can go back to your unit circle on the back page and look for all the different things that you can know about 45. But it's basically radical 2 over 2 for both the coordinates. So it has an x value and a y value of radical 2 over 2. It's going to make our job really easy. So sine is the y value, radical 2 over 2. I'm going to move that down and see if my board will let me write it a little nicer. So radical 2 over 2 for our y value, radical 2 over 2 for our x value. What would our tangent value be when you divide the two numbers? 1, very good. And you know that something that people didn't do on the quiz that they could have done is use the calculator to check. Type in tangent of 405 and see if you get 1. It's a great, great, great tool to check a problem like this. So is tangent of 405 1? Sure is, you know. You can do that. Cosecant, we would reciprocal to sine. Secant, we'd reciprocal to cosine. And tangent, or cotangent, we'd reciprocal to tangent. So thanks for watching. Thanks for watching part 1 of the video. The other part will have problems 1 through 11, okay? Like and subscribe and hit the bell and leave me comments. Love you, scholars. See ya.